All right, so now we know how to solve differential equations by separating the variables. But there's one equation that comes up so often that we just gotta memorize it, okay? That's this one. Like if we're in BC, there's two that come up often, but we're AB, so we're gonna have to know this one. So sometimes on the AP exam, they'll just give you this equation, or they might give it to you in words. They might say, the rate at which a population grows, if Y represents the population, is proportional to the amount present. See, so the rate at which, if Y represents a population, the rate at which it grows is this, right? The derivative is a rate. It tells you how fast something is changing. So the rate at which a population grows is proportional to the population itself, or to the amount that's left. Okay, and as you know from algebra and stuff, anytime you have like if they tell you on the ACT or something, Y is directly proportional to X, don't you write this? Right? K is called the constant of proportionality, or Y is inversely proportional to X. Then you would do it something like that. But anytime it says proportional, you have to have the constant of proportionality there. Just like in chemistry, right? Which is the one? Something is proportional to something. The gas law or something? I don't even know. I had a C- in chemistry. Anyway, so how do you solve this differential equation? We know how to do it now. We separate the variables. So what you do is you move all the y's on the left. So divide the y on this side, and then move the dt on this side. And then what's the second step?
Integral.
Integrate both sides. Okay, what's the integral of the left side? Natural log, absolute value of y plus c. But remember, we're going to mush two c's together. And the reason why we don't need to put the absolute value is because you have a population. There's always going to be a positive number of things in the population, right? You can't have a negative number of people, so we don't need to put the absolute value. Equals, and then what's the integral of the right side? And please do not say 1/2 k squared. K is a constant. T is your variable. So K is a constant, you can throw that on the side. And then what's the antiderivative of 1 dt? T. Right? Not X, because T is independent. See this thing over here, see this thing is so important. That tells you what your independent variable is. And then they both have a plus C, so we mush them together into just 1 plus C. Now normally we would give you an initial condition. Okay, but don't worry, it's going to be there. But let's worry about solving for y now. How do I get rid of this ln? You e both sides. So you got e to the natural log y, simply y, and then you got e to the kt plus c. Now this is the correct answer, except that's not how it's going to be. We're not going to remember it like that anyway. So what we do is we use our properties of exponents. So isn't this the same thing as e to the kt times e to the c? Right? Because when you multiply things, you add the exponents. And then if c is a constant, then isn't e to the a constant power a constant as well? And do you know what we call the constant? C. Yeah, we could call it c, but come on, from pre-calculus last year. Okay, I'll just tell you, why not? Why not is your initial population. Okay, so whatever this constant comes out to be, because just think about it, when you plug in 0 for t, what happens when you plug in 0 for t there? E to the 0 is 1, and 1 times this is just that. So whatever number you have here, that's how much you have at the very beginning. We call that y naught. So this is the solution to the differential equation. So, do you see all the work that we have to do just to get there?
Yeah.
We don't want to reinvent the wheel. In fact, tonight's homework, every single problem is going to be this. They're either going to give you this equation or this phrase. That's the solution. Because do you want to like do this like tonight's homework, maybe got 12 problems, you want to do it 12 times? No, you just memorize it. So whenever you see either this or this, that's your solution. Now, sometimes on the AP exam, they change the variables on you. And some of the problems on tonight's homework, they're going to do that too. But do not let that fool you. What if they said, okay, remember on the AP exam, they said the weight of a puppy, the rate at which the weight of a puppy grows is proportional to its weight. Is that going to throw you off if they use a W instead of a Y?
Yeah.
I hope not. So what is the solution for this differential equation here? What would you write? W equal W naught e to the k t. That's right. That's all you have to do. And sometimes they even mix up the variables like this. Sometimes they do this. dm dq is equal to km. See how it has the same form? You just memorized the solution already. What is the solution to this? M equal m naught e to the k q. You guys see that? So don't let the variables bother you. Just look at the form and write down the answer. Because if you're in physics, lots of times like Q, don't they use Q for charge?
Yeah.
And M is mass? Well, you could get a question like that. So what kind of problems are you going to see tonight? I'll just do one example. I think that's enough. So you guys ever heard of carbon-14? It's an isotope of carbon. What is the original number for carbon? Who's in chemistry?
C4.
Is it 12 or 16?
13. 12.
12, okay, carbon. So what does 14 mean? It has two extra somethings, yeah?
Neutrons.
Neutrons. What does that make it?
Neutral.
I don't know. I told you I had a C minus in chemistry.
Heavier. Yeah,
Oh, yeah.
Yeah, but what does it do?
Nothing.
Nothing.
More protons.
Okay, anyway, all I know is carbon-14 is an isotope which they use to do carbon dating. You guys learned that in chemistry, right?
Yeah.
What you talking about? Okay, anyway, so the equation you're going to use is y equal y naught e to the kt. You're going to use this on every single problem tonight. Okay, so now in most problems, the first thing you have to do is you have to figure out the value of k. Now in some of the problems, they actually tell you, so you don't even have to do that step. I would say half-half, okay? So they're going to say the half-life of carbon-14 is, I think most people use 5,700 years. Does that sound familiar? Who takes AP chemistry here? Okay, never mind.
No.
Okay, and maybe it's 5730, that's the number I use in pre-cal honors anyway, but I think in your book they just use 5,700. Okay, just based on this information, you can figure out the value of K. So what does this mean? The half-life of carbon-14 is 5,700 years. That means it takes 5,700 years for a given amount to decay to half of what it started with. So if this is your initial amount, remember this number in the front, that tells you the initial amount. If your initial amount is y naught, what is half of that?
Half.
1/2 y naught. And where do I plug that in? You plug it in for y. So you get 1/2 y naught, because that's your amount, right? Equals y naught e to the k, and then what do I plug in for t? 5,700, because it takes that long to decay to half. So 5,700. Now what do you know? The y naughts cancel out. They always do. It really doesn't matter what your initial population is. It's just that you have half of it. And notice that the only variable left you have to solve for is k. How do you solve for k? How do I get rid of an e? You natural log both sides. So natural log both sides. Natural log of e to the gorilla is gorilla. And then if you solve for k, k is natural log half over 5,700. So anytime you do a carbon dating problem, that's your value of k. I mean, if you want to memorize it, you can, but yeah, I think there's only one carbon dating problem on the homework, so I would just say go through the process. Okay, so now that we figured out the value of k, this is our equation. Y equal y naught e, but now we know what k is. It's natural log half over 5,700 t. So we can use this equation to carbon date. So suppose you guys are having a barbecue in your backyard, and then your dog starts digging. And then your dog brings up a bone and go, oh, that's a weird looking bone. So is this bone from the barbecue last weekend? Or is it from an ancient civilization long ago? How do you know? You take it to the laboratory, and then they'll carbon date it, and they'll tell you something like there's 45% of the original amount left. So whatever original amount there was in the beginning, there's only 45% of it left. Can you figure out how old the bone is?
Yes.
Yeah, you just use that equation. So if this was your original amount, there's only 45% of that left. Now what would that be?
Yes.
0.45, why not, right? Where do I plug that in?
Y.
You plug it in for y, so 0.45 y naught equals y naught e to the natural log half over 5,700 t. Y naughts cancel out, they always cancel out. And what's the only variable left to solve for? T. That tells you the time it takes it to decay to 45%. So if you solve for t, that's going to give you the age of this bone. Okay, so again, how do you get rid of an e? You natural log both sides. So natural log 0.45 equals natural log of e to the banana is banana. And then finally, if you solve for t, just multiply both sides by 5,700. And then divide that by the natural log 1/2, or you can put 0.5 if you want. And there you go. That's the age of your bone. In fact, why don't we put 0.5 there? Okay, now this number probably means nothing to you, so that's why you punch it in on your calculator. Since you have two on your desk. More welcome. Okay, Connor Lee. Punch it in on your calculator and you get, give me 3 decimal places.
6,566.418.
Say that again, 6,000.
566.418.
So that's how many years this bone is, years old. So it's not from the barbecue last weekend. It's from an ancient civilization long ago. So what would happen if you find this bone? What are you going to do with it then? Throw it away.
Yeah.
No! You take it to Bishop Museum and they're probably going to say, oh my gosh, you know what? We want to excavate your house, like, you know, dig up stuff in your house. We'll buy your house for $5 million. Okay? And then you're rich.
How do you even know that it's 45% of a bone?
I don't know. I asked somebody, I asked a chemist once and they told me they have a machine, you put it in and it tells you that.
Like, that's such a...
But this was like 20 something. I can't even remember the chemist I asked.
Well, it's like this much of a bone that's like this big. You don't even know what kind of bone it is.
Well, that's why if somebody was in AP chemistry, they could tell us.
Unfortunate.
Yeah, well, don't ask somebody who got a C- in chemistry. All right, so that's the kind of problems you're going to see tonight. Every single problem, you're going to use this equation. So yes, it might be confusing because sometimes they'll give you an equation. Like I said, like, what if they give you this? dy dt is equal to negative 0.793. Let's just put negative 6.693y. Isn't that the form? Well, I erased it. So as soon as you see that, you just write this. Y equal y naught e to the negative 0.693 t. Oh, t. Remember, whatever, this is the K. See, the K is right there. So you gotta practice reading the problem because you don't know how it's gonna be stated on the AP exam. Sometimes they give you the equation, sometimes they write it out in words. All right, so it's really not that difficult. So we are done then. We're done with this chapter. So next time I see you, there'll be a practice worksheet, and then I believe the test is next week, Tuesday.
Is this problem only gonna be in the calculator section?
No, because sometimes they'll just give you numbers and then this is your answer, and then you look. Oh, since we're all gonna ask that question, what if this was multiple choice? What if this was multiple choice and you got this, which is correct, but you know they're gonna only give you 4 answers, and I guarantee you, it's not gonna look like that.
Oh,
So how could they write the answer? You use your properties of logarithms there. So 5700, this is how they test to see if you know your trig identities, properties of logarithms, and so on. Like, what would be another way to write this? Well, change it to fractions. What is 40.45? 45 over 100, right? Which can be reduced to
9/20.
9/20. 0.5 is 1/2.
120.
Natural log, what? 1/2, 1/2.
How about 0.05?
So what could be another way they could write this? Well, isn't natural log 9 over 20 the same thing as, remember your properties of logarithms?
No.
Natural log 9 minus natural log 20. What about 1/2?
Natural.
Natural log 1 minus natural log 2. But what is natural log 1?
Negative
0. So this is 0, so you have this. So they could write the answer like this. 5700 times natural log 20 minus natural log 9 over natural log 2.
No.
Would you be able to pick out the answer?
No.
No.
What do you mean, no? This is pre-calc, this is algebra 2 stuff. That's why we're,
How do you even get that? Wait, how do you get ln 20 minus ln 9?
You just.
I put the negative, I take this negative sign and distribute it on the top.
Yeah, I know.
What do you mean?
Right there.
All right, don't get upset. Just start uploading the video. Question?
How do you remember properties of exponents versus properties of logs?
Because you took years of algebra.
Yeah, what are all the properties of?
Don't worry, don't worry. I will tell you what's important. That is not that important in the scheme of things.